Welcome to my presentation. In this presentation we shall see how to identify the order of a matrix. So let us look at some simple examples. Let's say we have a matrix like this: 1, 2, 3, 4. In here the matrix has two rows. It has two rows and two columns. So therefore the size of this matrix is a 2 by 2 matrix. Let's take another example. Let's say we have 1, 2, 3, 4, 5, 6, like that. So we have two rows. Let me write in black here so therefore you can see better. You have two rows and three columns. Two rows and three columns. So therefore this would be a 2 by 3 matrix. The first number always represents the rows, the second number always represents the column. So the first number always represents the rows, the second number always represents the column. The first number always represents the rows, number of rows, and the second number always represents the number of columns, the rows and columns. Okay, so that is one easy way to remember things. So let's look at another example. Let's say this time we have 1, 2, 3, 4, 5, 6, 7, 8. So if this is the matrix we have, we want to first identify the number of rows we have. We have row 1, row 2, row 3, and row 4. This is column 1 and column 2. So we have 4 rows and 2 columns. So this is a 4 by 2 matrix. This is a 4 by 2 matrix. 4 rows and 2 columns. Okay. Let's see if we can represent some more examples related to this. Let's say we have a matrix of this size: 1, 2, 3, 4, 5, 6, like that. In here we have one row 1, but we have, this is column 1, column 2, column 3, column 4, column 5, and column 6. So we have one row and 6 columns. So this is a 1 by 6 matrix, 1 row and 6 columns. This is a 1 by 6 matrix. Okay. So what if we have a matrix like this? Let's take another example. Let's say we have 1, 2, 3, 4, 5, 6, 7, like that. Let's say we have a matrix like this, and we want to determine the size of this matrix. So we have, that is row 1, that is row 2, that is row 3, that is row 4, row 5, row 6, and row 7. And we have one column. So we have 7 rows and 1 column. So therefore this is a 7 by 1 matrix. So we want to make sure the number of rows, and that number comes first, and then the number of columns, then that comes second. So depending upon the numbers of rows and number of columns, we determine the size of the matrix. And lastly, if we have an example like this, 0 and then just no other elements in there, so how do we represent this? We have, that is row 1. It is in the it has one row and it has one column. So therefore the size of this matrix is going to be equal, since we have one row and then one column, the size of this matrix is going to be 1 by 1 matrix. So this is how we can represent the order of a matrix. In my next presentation we shall see what an augmented matrix is and what a coefficient matrix is.